again from ECMWF, Christel Prudhomme, that will tell us a little bit on the Aristotle initiative. Christel, over to you. Thank you.
Hello, thank you. Can you see my screen and can you hear me?
Yeah, it's perfect. Thank you so much.
Good. Thank you. First challenge gone. Thank you very much for this kind invitation to be part of the discussion. And I want to thank my co-author who prepared the slide, actually, Callum Ball, and all the forecasters of the Aristotle Flood group who are behind this work. So what is Aristotle? Well, Leonardo earlier talked about the need of technical translator. This is exactly what Aristotle has been designed for. And now I'm trying to change the slide. Here you go. So it's a partnership that's started in 2016. And that was basically to help the Emergency Response Coordination Center from the European Union to be better prepared to have some more understanding on potential natural hazards. So they got all sorts of experts at the ERCC, but they can't be experts in everything. And basically they realized that they needed this translation between what various forecasting systems were showing them to, and kind of understanding, summarizing the key information. And there are 6 main natural hazards that are considered within this partner or by the partnership. 3 of them are what called forecastable. They're linked with weather, and they what we call severe weather, which are tropical cyclones, big winds, flooding, and forest fire. And there are other hazards, which are earthquake, tsunami, and volcanoes, where it's much more difficult to have forecasts. And what this partnership is doing is provide guidance to the ERCC. So then that help the ERCC anticipate perhaps some response actions. So what do I mean by that? Well, how it works is that the Aristotle partnership look at all sorts of information and write what's called a routine report, monitoring report, to assess the current situation or what is forecasted to happen in terms of forecastable hazard. That happens on Monday, Wednesday, Friday, where each hazard report events that have happened or are forecasted, put a summary through the RCC. So they are aware of things, and they start even to assess the severity and the potential impact of those events. And then sometimes there are emergency reports, and these are triggered either by the ERCC or by Aristotle themselves when there is an event that is deemed to be a much higher impact. There were, here on the map on the bottom right, you can see we had nearly 30 activations in the last year. For all sorts of hazards, and some activations include several hazards. So for example, flood that had happened following a tropical cyclone in Mozambique combined both the severe hazard and the flooding report. And once this emergency report has been activated, then the Aristotle Consortium had 3 hours to provide a detailed report to the ERCC. So now digging up to really the flood service, it's a global service, so it means global coverage, and it's delivered by a consortium of 4 organizations, and they're organized in weekly rota. So one organizations take on the duty of forecast analyst for 1 week with a deputy organization in case of issues, and that changes every week. And they work both at weekdays and weekend. And then there is also an organization rota, which is kind of a change in the annual basis. And this is to have the linkage with the rest of the hazard, the management, provide training, etc., define procedures. And basically, I said it was a global coverage. but with the slight differences because of the tool and the level of information we've got. For Europe, we go to rivers which are more than 2,000 square kilometers to kind of officially. Of course, we also look at smaller rivers, but this is where we've got most confidence in our information. And for the outside Europe, it's larger rivers because of the scale of information. So talking about the information and basically the information that needs to be translated and is translated by Aristotle, we use mainly the two operational systems of the Copernicus Emergency Management Service, so the European and the global flood awareness systems that provide updates daily or twice daily for the European system on flood hazard and having a vision for the next 10 days. But in addition to those systems and sometimes to confirm the signal, we also look at additional systems, and we use at the moment the worldwide HYPE from SMHI. And for looking at impact, and impact was mentioned as something really important for having actionable information. We'll also look at the DEWETRA platform, but there are other sources which are also looked at. But what's important is that there are well-established protocols, that training, guidance in the terminology that is used and the content of the reports that are set up and are followed by the forecasters on duty. So then there is a consistency, even if there are different people and different organizations providing those translations, the reports are consistent. So just to go through very quickly to sort of what could have happened, you all remember the devastating floods that happened this summer. The map on the left show you the level of precipitation that had happened, and we all know that there are some fatalities that had happened. So what sort of information the forecaster on duty, and I believe that it's the CIMA Foundation that was that week on the Aristotle duty, where these are show of 3 layers which are available on EFAS, and I'm going to go through them very quickly. We've got one layer that highlights impact regions where EFAS estimates that the highest flood impact are possible in the next 10 days. So that draw the attention of regions that might be the most impacted by flood. Then there is another information, which is when is the flood going to happen? And there is this layer about showing the flood probability in the next 48 hours. So it means the action needs to be really quick. And the darker the color, the highest the confidence in the flooding being exceeding 5 years return period. And then the last information that is really used often is there are some points which we call the reporting points that highlight rivers where there is a signal of flooding, but where some additional information is provided by the flat platform. And this additional information is shown in the form of hydrograph with the uncertainty bars due to the ensemble forecasting, created by the ensemble forecasting is shown, and there is a background showing the level of severities. And even though here you can see that there is quite a range in the severity of the flooding, there is a strong signal that the flooding might happen in the night between the 14th and the 15th of July, and that's from the forecast delivered at from the runs of 00 UTC, the 14th of July. So what other information the analysts are looking at? Well, they're very interested in looking at what's happened in the past. So how much rainfall has already fallen, but also how wet the soil is, because we all know that if you've got rainfall falling on the wet soil, that the risk of flooding will be higher. So those initial conditions are really important. And then they kind of look at whether there is a signal of heavy rainfall, which is forecasted in the next 10 days, and whether they're in the same locations than where you had already had rainfall and heavy soil moisture. And again, there is still these things about let's confirm the signal. So EFAS, as I said, produce forecast actually every 6 hours. And here, this is like a summary of the timeline of what had happened. So the first slide on the top left diagram showed the probability of flooding, which exceed for the 5-year return period, but which is beyond the next 2 days. So between the next 2 and 10 days, you can see that the darkest colors are the highest probability. There is a bit of signal, and we had seen, this rainfall that had happened, heavy rainfall. But then when you go through time, it looks like more and more a wider area shows some strong signal, and the signal intensifies, the colors are bigger. Here, dashed is a Monday report. So already on Monday, we could provide a report to Aristotle saying alarm bells is happening. And then on Tuesday, that also confirms the signal. Happening Wednesday now switching to a different layer that says what's the probability of flooding in the next 48 hours, you see that we've got a strong signal. Interestingly enough, and I'm going to mention that later, is that there is an area which are the worst affected area that was not seen by EFAS, but this is because it's smaller rivers, and smaller rivers that are more difficult with the type of modeling we've got at the moment, and the resolution is not sufficient to have a high certainty in that signal, and you'll see that the consistency in the signal and the significance is has been shown in the next day. So all that information is really used by the analyst to then write that report. And an emergency was activated, emergency report was activated by the ERCC. So the forecasting duty wrote it, and what this report is containing basically information on the hazards, in that case, the flooding, what's the hydrological situation, when it's going to happen, where is it going to happen, what's the severity of the forecasted event. And then there is an impact, which is a section which is really important, and had been mentioned already, is this concept of impact. And there is a layer in EFAS and GLOFAS that have a very gross estimate of a potential impact in terms of categories. There are other tools, I mentioned EWITRA, about kind of having impact and say, what's the level of severity? How many people, how much infrastructure is going to be impacted by that event? And that information is really critical for the ERCC to understand whether they might be themselves asked to coordinate for a response. So now you all know there is no perfect system and no perfect service. So we always think about future development, and we try to prioritize them because they require resource, they require scientific development, they require infrastructure, technical processing. And so one of those developments, and somebody had asked questions, what are the needs for improvement? Certainly for Aristotle point of view, is kind of looking at flash flooding. This is not well done currently with our 2 EFAS and GLOFAS systems. So could be improved the spatial resolution. It could be providing a better post-process forecast, but this is something that had been highlighted as really missing because it can be extremely impactful. Second area is those kind of improving perhaps better the impact through a more accurate understanding of the footprint of the flood, the inundated area. Was the current situation from monitoring and remote sensing, maybe what's a better forecasting of those inundated areas could be working. And then there is a third element. I mean, there is many other process improvement, of course, that can happen, but one element that is always kind of something that is asked by users, and in particular, users being also the translators, is how much confidence do I have in the signal I see from those services? Can I be confident to tell the ERCC, yes, an event is going to happen? And that's really, really difficult. So the first thing we've started introducing is maybe looking at the confidence in some sort of skill metrics in the way the hydrological system is reproduced. But then we can add confidence about how the forecasting skill, and we can add more things. But this concept about the confidence in our information is really critical and something that needs to be further advanced because it's complex. So I'm finishing now. I'm sorry, I'm just over the 15 minutes, I think, so we don't need to develop more, but basically what Aristotle tries to achieve is this technical translation, and we need to get better at that. Thank you very much.